Welcome back to Start Learning. In this video, we will start the series of lectures on deterministic and stochastic statistical methods, which is in 2-2 in the Jntua curriculum. So, this is the M4 examinations, which is very difficult. So, in previous years also, the question paper is very difficult. That's why you just try to concentrate more on this subject, then only you will get succeeded. Okay, so without wasting time, we'll skip to the first unit. So in first unit, we will discuss about these distance measures and the projections, notation of half planes and hyperplanes, and principal component analysis, which is a very important concept in this unit. And then, so in the principal component analysis itself, we'll discuss about this population principal components and simple principal coefficients, covariance, and a matrix of the data set. Likewise, we will discuss everything in this principal component analysis itself. Next, dimensionality reduction. So these things and all we'll discuss later. So singular value decomposition as well as this gram scheme process. These two questions are very important. That's why you have to concentrate more on these topics, that is singular value decomposition as well as the gram scheme process. Okay, principal component analysis also. Now in this video we'll discuss about the first unit in the unit 1, that is distance measures. Okay, so distance measures, we have different types of distance measures such as Euclidean distance, Manhattan distance, Hamming distance, Minkowski distance, Zagat distance, cosine similarity. So these are the some distance measures which we use in the machine learning as well as in the daily life basis also. So distance measures plays important role in the machine learning. Why? Because almost in the machine learning we are going to deal about these data sets and all. As we know, the machine learning is broadly classified into two types, that is supervised machine learning and unsupervised machine learning. So in the supervised machine learning, we have the KNN algorithm. In KNN algorithm, we have to concentrate on these distance measures, as well as in the unsupervised machine learning, we have the clusters. Okay, that is K means clustering is there. K means clustering. Likewise, we have these categories. Okay, so different distance measures must be chosen used depending on the types of data. As such, it is important to know how to implement and calculate the range of different popular distance measures and the institutions for the resulting scores. So by the end of this course, you will be able to see about the roles and importance of the distance measures in the machine learning and its algorithms, how to implement and calculate the Hamming code, Euclidean and Manhattan distance. So these are the distance measures which we are going to discuss in this video. How to implement and calculate the Minkowski distance, and generalizes the Euclidean and the Manhattan distance. Okay, Euclidean distance and the Manhattan distance. These are the distance measures that we discuss over here. Now, so we'll see the first distance measure, that is Euclidean distance. So the Euclidean distance is one of the most commonly used distance measures. It is calculated as a square root of sum of the differences between each points. Okay, so as we know, basically this is how we will find out the distance between 2 points, right? So square root of x1 minus x2 whole square plus y1 minus y2 whole square. Likewise, we will find out the distance. So this is how the Euclidean distance works. Okay, for algorithms like k nearest neighbor, that is KNN and the K means, it is essential to measure the distance between the data points, right? So we have to measure the distance between two data points in these both the algorithms. In KNN, we calculate the distance between point to find out the nearest neighbor, and in the K means clustering, we find out the distance between the point to cluster into groups. That is, we have to group that into clusters, right? So this is how which we use these distance measures. It's vital to choose the right distance measure as it impacts the results of our algorithms. So as we know, in machine learning, we have to get the accuracy. Okay, so when we choose the particular algorithm for that is the correct algorithm for solving our algorithm, in the sense, at that case we'll get the more accuracy. Otherwise we won't get the more accuracy, right? So that's why we have to choose the right distance measure. Okay, so this is how this point tells. In this portion we'll see some standard distance measures used in the machine learning. Okay, see here, as I already told you that, so Euclidean distance is used to find out the distance between 2 points. Assume that this is x1 and y1, and then here we have x2 and y2. So if I wanted to find the distance between these 2 points, in the sense, so this is what the formal notation of the Euclidean distance. But when we come to the formula, so that is x1 minus x2 whole square plus y1 minus y2 whole square. So this is how under square root. Okay, so this is how we'll find out the distance between 2 points. So in simple word, Euclidean distance is the length of the line segment. So that's what I told you. Also, when we found out this particular distance, in the sense, so that is nothing but the length of the line segment, right? So Euclidean distance, see here, it is also called an L2 norm of a vector. So in the examination, they may ask so discuss briefly about L2 norm of a vector. L2 norm of vector. So you have to understand these things. So L2 norm of vectors, in the sense, that is nothing but the Euclidean distance measure. Okay. Then so this is how in the previous slide itself I told you. As we know, these can be found by using this Pythagorean algorithms. So you people may know about this Pythagorean algorithm, right? So Pythagorean theorem. So whenever we have the what right angle triangle, so hypotenuse square. Assume that this is so hypotenuse square equals to, that is c square equals to, if you wanted to find out the hypotenuse distance, in the sense that this can be measured by using the square of adjacent plus the opposite, right? So likewise, so if I found wanted to find this distance, in the sense, c equals to the square root of a square plus b square. So this is not that much important. Okay, so this is how this particular Euclidean distance can be calculated. Okay, and then we'll discuss about this Manhattan distance, which is the second distance measure which we are going to discuss here. So this is also called as, see, Manhattan distance is also called as the L1 norm of a vector, but that Euclidean distance is called as L2 norm of vector. You have to be clarity among these two. Okay, so L1 norm of a vector, in the sense, Manhattan distance, L2 norm of a vector, in the sense, that is a Euclidean distance. Okay, so Manhattan distance is also is calculated as sum of the absolute distances between the 2 points. So you just remember, you just take this definition itself. So while solving the problems, you can easily understand what is Manhattan distance. Okay, so simply make a note that Manhattan distance is L1 norm of the vector. Manhattan distance is calculated by using what, like this, sum of the absolute distances between 2 points. Okay, so this is what the Manhattan distance is. And then, so the third distance measure is the Chebyshev distance. Okay, this is Chebyshev distance. So it is calculated the maximum of the absolute difference between the elements of the vector. So we are going to find out the absolute difference between the points. So among that absolute differences, we are so Chebyshev distance is the maximum of the absolute differences. Okay, so Chebyshev distance is the maximum of the absolute differences. So please make a note that, so Chebyshev distance is nothing but maximum of absolute difference between the elements of the vectors. Okay, so this is what the formula for this. So don't worry, though you are not understand these particular slide, so you will clearly understand while solving the examples. Okay, so it is called the maximum value distance. Okay, so Manhattan, see here, so three notations are involved. So Manhattan distance is a L1 norm of a vector, Euclidean distance is the L2 norm of a vector, Chebyshev distance is the maximum value distance. Okay, and then here is the main thing. that is Minkowski distance, which we popularly use in the machine learning algorithms. So Minkowski distance is just a generalized form of the above distance measures. Okay, so this Minkowski distance is the generalized form of all the above distance algorithms, so distance measures which we have discussed. So we have discussed about this Euclidean distance, Manhattan distance, and Chapa distance, right? So Minkowski distance is the generalized form of the above distance algorithms. Okay, distance measures. So Minkowski distance is also called as p norm of the vector. See here, p norm of the vector. You have to make a note that this is p norm of vector. P norm of vector. So Minkowski distance is measured as p root of the absolute difference. What distances? Okay, see here, p root of absolute distances over the p. Okay, so Minkowski distance for different values of p. So if p value is 1, then that particular distance measure is Manhattan measure. So if we substitute p equals to 1 in this particular formula, in the sense, so that distance measure is known as Manhattan measure. When p equals to 2, that distance for that particular distance measure is the Euclidean distance. When p value is infinity, at that time the distance measure is Chapa distance. Okay, so when I substitute infinity over here, so this particular value only remains. So that's what I told you in the starting itself. So this Minkowski distance is a generalized form of the above 3 distance measures which we have discussed earlier. Okay, now we'll discuss about the Hamming distance. So Hamming distance, it's very simple distance measure which we are going to work out on the strings. Okay, so we use Hamming distance if we need to deal with the categorical attributes. So you just leave about it. So we'll go to the example. Wait, Hamming distance measures whether two attributes are different or not. Okay, so assume that we have the two strings, we have to compare that two strings, and we have to give the result as whether they are same or not, likewise. Okay, so when they are equal, the distance is 0. So if the given two strings are equal, then the distance is 0, otherwise it is 1. Okay, so the output of this Hamming distance, is 0 or 1. Okay, see here, we can use a Hamming distance only if the strings are of equal length. Okay, so you have to make a note that, so we can only perform this Hamming distance whenever the strings are having the equal length. Okay, see here, in this case, for example, let's take the two strings, hello world and hello world. See here, so the strings are of equal length. Yes, it's of equal length. We have to check whether these two strings is similar or not. The Hamming distance between these two strings is 2, because as the string differs in the two places. See here, h, yes, it's mapped, and then e, so it's not correct. So this one is not correct, likewise. So it is 1, and then l mapped. Next, o mapped, w mapped. But see here, o a. So these particular strings are deferred at two places. That's why the Hamming distance between these two strings is 2. Okay, so this is how Hamming distance works. So hope you got clear about it. Okay, next, it measures the next distance measure is cosine similarity. So it is nothing but the cos of the angle between the two vectors. Okay, it measures the cosine of angle between the two vectors. So assume that these are the two vectors. So this is what the angle between them. So cos theta is the cosine similarity between those two. Okay, so here cosine similarity ranges from 0 to 1, where 1 is the two vectors are perfectly similar. Whenever we get the cos 0, in the sense what, see here, whenever, where 1 means the two vectors are of perfectly similar, because so the two vectors lies on each other. Okay, at that case the vectors are similar, right? So that's what mentioned in this point. So if the angle between two vectors increases, then they are less similar. Yeah. So this is what the basic thing. Assume that we have the two vectors as like this. So if these two vectors lies in the same line, at that case it is similar. So whenever the angle is increasing like this, in the sense, at that case that a particular what that particular vectors becomes less similar. Okay, so this particular similarity, cosine similarity, is calculated by using this formula. Okay, next, cosine similarity cares only about the angle between the two vectors, and it's not the distance between them. Okay, cosine similarity, it only deals with the angle, it's not deals about the distance. Okay, we'll discuss one example, then you'll come to know what is this cosine similarity and all. Okay, so this is the simple explanation regarding this. Assume that there is another vector c in the direction of b. Okay, see here, assume we have the two vectors and one more vector is there in the direction of b itself. So what would you think the cosine similarity would be between b and c? So the cosine similarity between b and c is 1, since the angle between b and c is 0. So that's what I told you. Whenever two vectors lies on the same line, in the sense, at that time the angle between them is 0, right? So then cos of 0 is 1, that is these two vectors are similar. That's what we discussed in this particular point. Okay, cosine similarity ranges from 0 to 1, where 1 is the two vectors are perfectly similar. So that's what the case here. Okay, even though the distance between B and C is large comparing to A and B cosine similarity. Yes, we discussed about the cosine similarity cares only about the direction of the vector. So it's not the distance. Okay. So that's what the cosine similarity is. Now we'll discuss about this Zagat similarity. So in Zagat similarity, instead of vectors, we are using sets over here. Okay, sets. We are going to perform actions on these sets. So it is used to find the similarity between two sets. Zagat similarity is defined as intersection of the sets over the union of sets. Okay, so this is what the formula for the Zagat uh, similarity and their distance. So Zagat similarity is defined as the intersection of sets divided by the union. Okay, Zagat similarity between two sets is going to find like this. So Zagat distance, we use Zagat distance to find how dissimilar two sets are. So if we get one, Zagat similarity will give you the one Zagat similarity will give you the Zagat distance. Okay, let me explain with one example. Assume that we have two sets A and B. A is having 0, 1, 2 and 3, and we have and in the set B we have 1, 2, 3, 4 likewise. So the intersection of these sets is what the common elements in these two, that's what the intersection is, and then union. So we are going to perform the union operation. When we perform the union operation, so we are going to take only the length. Okay, the length of the set. So A intersection B is 0, 1, 2, 3. So here sorry, 1, 2, 3 are the common elements, right? So 3 over, so union, when we perform the union operation, here we have 0, 1, 2, 3 and 4. Okay, so likewise, so when we perform this, we'll get the answer. So this is what the Zagat similarity is. Okay, now we already discussed about this Euclidean distance. Here is a what a detailed description about this Euclidean distance. If you want, in the sense, you can take this screenshot and you can go through this. So everything is similar. Okay, what is Euclidean distance formula? This and all we have discussed over here. And next Euclidean distance formula is, as I already discussed you, that is a square root of it may be x1 minus x2, or it may be x2 minus x1, whatever it may be, but the results will come. Okay, likewise. So this is what the derivation of this Euclidean distance. It might be asked in the 2 marks itself. So if you want, in the sense, you just take this screenshot and go through this. So it's a very similar one. That's why I'm not going to explain in depth about this concept. Okay. So this is what the example. So we'll see about we'll go through these examples. Then your understanding would be clear about this distance measures. So find the distance between 2 points. So see here, we have given the 2 points P and Q. P, so assume that x1 and y1, and Q, assume that these two are as x2 and y2. So you just substitute in this equation, then we will get square root of 2 units. Okay. So then the Euclidean distance between these points is root 2. So this is what the simple calculation. That's why I am not getting in depth so into these examples. So you can pause my video and you just proceed to do. Okay. Prove that the points A, B, C are collinear. Collinear in the sense that might be lies on the same line. Okay, so that's what the collinearity tells. Okay, so to prove the given the 3 points are collinear, it is sufficient to prove that the sum of the distances between the 2 points is equals to the distance between the third pair. So we'll find out the distance between the other pair. So first of all, assume that this is the as x1, x1, y1, x2, y2, likewise. Okay, assume that x1 y1, x2 y2, and x3 y3. So you can you have to find out the distance between AB, and you have to find out the distance between BC, and you have to similarly you have to find out the distance between this A and C. So whenever the distance, that is sum of the two vectors distance is equals to other vector in the sense, so at that case that is said to be collinear. Okay, that particular vectors are said to be collinear. So it might be asked in the 2 mark questions itself. So go through it and then check whether the points. So here they are given that the 3 points are the vertices of the equilateral triangle. So what is equilateral triangle? Equilateral triangle is something, but all sides are equal, right? So we have to find out we have to compute the distance between these 3 points. That is, so we have to find out the distance between AB, we have to find out the distance between AC and BC. So if the distance between AB and AC and BC are the same, at that case that particular triangle is said to be equilateral. Otherwise, that triangle is not the equilateral triangle. Right. See here. So you just substitute everything in the Euclidean distance formula. So you will get, see here, AB distance is 2 and BC distance is 2, and then CA distance is what? Root 34. That is AB, BC are having the same length, but CA is differs. That's why the given points doesn't form a equilateral triangle. Okay, so this is what the important questions that is important 2 marks questions which is going to be asked in your university examinations. See here, what is Euclidean distance formula? You know that Euclidean distance formula is used to find out the distance between the 2 points. So assume that the points are x1 and y1, x2 and y2. So that Euclidean distance is measured as d equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. How to derive Euclidean distance formula? In the previous slides itself, I told you that. So you can take a snap of it. Go through that. What derivation of this Euclidean distance formula, and then what are the applications of the Euclidean distance formula. So the Euclidean distance formula is used to find out the length of the line segment. I already told you that. So it's used to find out the distance between 2 points. So if you are finding the distance between 2 points, in the sense we are finding the length of that particular line, right? So that's why it is used to find out the length of that is what length of the line segment. Finding the distance helps in providing the given vertices to form a square. So yes, absolutely. By using the distance itself, we are saying that. So whether it is an equilateral triangle or it's a square or it's a rectangle. So likewise, okay. See here, we can find out the whether the given points forms an equilateral triangle, rectangular, likewise a right angle triangle, etc. Okay, these are the applications of the Euclidean distance formula. So what is the differences between Euclidean distance formula and the Manhattan distance formula? See here, assume that we have the 2 points. So Euclidean distance formula says that the distance between the above points is, so this is what the formula for the finding of the Euclidean distance. But when we come to the Manhattan distance, so the Manhattan distance is computed over like this. Okay, so this is what the formula for this. Okay, see here, please try to make a note of it and go through it once, so you will be able to understand. Okay, now we'll go through the formulas. So we'll go through the formulas as well as the problems using this Euclidean distance, Manhattan distance and Minkowski distance. Okay, so distance between the objects. So here they are given the two vectors, that is two tuples. Okay, here they are given the two tuples, and we have to compute the Euclidean distance, we have to compute the Manhattan distance, and we have to compute the Minkowski distance. So you just go through the previous slides which we have discussed about this Euclidean, Manhattan and Minkowski distance, and apply these in this formula in that formulas. Okay, see here, this Euclidean distance, I already told you that Euclidean distance assume that this is as x1, this is as y1, this is as z1 or u. That's your wish. Okay, you can take in your own way. Z1, the this is as what, something what you want, S1 likewise. So the Euclidean distance is measured over like this. So you can go through, you have to practice the everything, then only you will come to know how to find out these distance measures. Okay, likewise you can find out that yeah, what Euclidean distance. I am not going to stress anymore in that Euclidean distance, because we have discussed about the three example in this in the Euclidean distance. That's why I am not going to stress that problems anymore. Okay, and then see here this Manhattan distance. So in the previously we discussed in the 2 marks itself the difference between Euclidean distance and the Manhattan distance. So this is how the Manhattan distance is going to be computed. Okay, so see here, we are going to find out the absolute differences between the points, these points. Okay, so and then we are going to sum up those values. See here, 22 minus 20, likewise. So 1 minus 0, 42 minus 36, 10 minus 8. So we are going to add that particular values. Okay, so this is how the Manhattan distance is going to be fine. Okay, and then we'll discuss about this Minkowski distance. I already told you that Minkowski distance is p root of x1 xi minus yi whole power p, right? So here they are given the p value as a 3. So here they are given a p value as a 3. So then you are going to substitute that particular values, that is these values, or in the formula itself. So when you substitute and compute these values, you will get the this particular result. Okay, so you can pause the video and you just try to execute, you just try to solve the problem, then only you will come to know how these distance measures will be worked. Okay, so thank you. In the next class we'll discuss about the hyperplanes, subspace and the half space. So as we know, this DSSM, deterministic and stochastic statistical methods, is a very complicated subject. Please try to concentrate more on this subject, otherwise you will be failed in your university examinations. So hope you understand everything. So if you are not understanding anything in the sense, you just try to mention in the comment box what are the problems that you are facing, then I'll come to know what you people are facing. So okay, please don't forget to share with your friends. So the knowledge is nothing but, so you are not going to store your knowledge with yourself, so you just try to share with your share to others, then only your knowledge will be increased. So that's what the motto that I am going to follow. Please, if you like what if you understand the content in the video, don't forget to like, and please try to subscribe and turn on the notification button. If I upload any videos into the YouTube, the time you will get notified. Okay, so kindly share with your friends. Don't forget to subscribe. Thank you.